everyone, this is Arman Gupta. This is the first video of my channel Codestur. So I'll introduce myself first. So I am currently a second year BTech student at IIT Jodhpur in the Computer Science Engineering department. So what we are gonna do on this channel is that we are going to learn some specific courses related to C++, and the thing that we are going to begin with is a programming language. So we'll start now. Like lots and lots of programming language exist in this world, some of them being Python, C, C++, something like that, most of them Java also. So the programming language that we are gonna start is C++. Fine. The first thing that you need to know as a programmer is, what do you mean by a programming language? So a programming language is a language that is understood by computer. So let's see in real life. Any particular human like us may speak a particular language like English, Hindi, French, German, anything. Okay. The computer does not speak any language. So in order to interact with the computer, we use a language called programming language. So actually, why a programming language is needed? So why did we build computers actually? We built them to perform our tasks, we build them to perform our task, our own task, so that they can do it. So in order to communicate it to them that this particular task is the task that you need to do, we need a programming language so that we could communicate to the computer, that the task. We need to communicate to the computer the task that we want it to do. So this is where programming language comes into play. Okay. So what the next term that you need to learn is, what is a program? So a program is just a set of instructions that you want to give to the computer. Like as we got earlier, what we made computer for, to do some task, and we need to give those instructions to the computer. So to give those instructions, we need a particular programming language, and all the sentences, all the description that is written in this programming language line by line is called a set of instructions, and that is being referred to a program. So this is what a program means in terms of a computer. Okay, that's it. So this is just the basic part, belongs to every language. The next thing that is going to be language specific, that is a basic C++ program. Okay, the basic C++ program looks like this: hash include, iostream, using namespace std, so this is std, int main, and this is cout, this is the operator, and this is hello world, and then return 0. Okay, so I'll just make some changes here. So this is hello. So what this basic program is gonna do is that it is just going to print hello world on the screen, just as suggested. Hello world is only the text that we are familiar with. We don't know what all this text means except this hello world. We know this is a normal text, and this is going to be printed on the screen. So the first observation that you're gonna get from this basic program is that anything written ahead of cout in the program is going to get printed on the screen. That's it. The first basic observation that you need to know from here. Okay, so time being, you need to just by heart this program. Like, you'll not understand what does this program mean, but you need to just by heart this program, because we are going to study it line by line. Like when we'll cover some topics ahead, then you will be able to understand what does line by line meaning of this program exists. Fine. So until then, you need to just learn. So one more customization that we can do is that just remove this hello world and write this word Codestur. So as simple as that. The thing that would be seen on the screen is this word Codestur. This is what basic program tells us. So you need to just by heart this, until you get to learn all the meaning of this program. Fine. Next topic that we are going to start with is variables. Okay, so let's suppose a case. There are two apples existing. This is apple 1, this is apple 2. Both of them are exactly same. You cannot differentiate it. Okay, we just kept them in a same container, single container, and I just tell you to differentiate between the two. This is impossible. You just cannot differentiate between the two. So then we move on to next case. I just take two containers, one of this orange color and the other of this green color, and I put two same apples into the container. Fine. And now I tell you, please differentiate between the two apples. Now the distinction is existing. One of the apples is being placed in the orange container, and another apple is being placed in the green container. So if someone asks you which one is this apple, you can just tell them this is the apple which is the one being placed in the orange container or being placed in the green container. So once we introduced containers for a particular object, we could easily differentiate between them, provided that the containers are different. So this is what variables do in a programming language. So what does a variable mean? It is just a data container. Like in a programming language, there would be a need to store some data, right? You are getting some data into the computer and you are just storing it. So the container in which this data is going to get stored is called as a variable. Just like the container here, you can see a container in which this apple was stored, so that the apple got an identity. Similarly, the data is going to be stored in a container so that it gets an identity. Fine. Again, we move on to another example. Let's say this is x is equal to 5. This is y is equal to 5. Okay. Let's suppose we do an operation y into 2 is equal to 10, and we do an operation x into 2 is equal to 10. Like both of them give the same output. There is no difference, but you can see is that 2 is being multiplied with y here and 2 is being multiplied with x here. The difference is that both x and y are 5, but the 5 is being stored in different containers. Like this 5 is for x and this 5 is for y. This is the significance of the container. The value being the same, the container becomes different, and the values, like the significance of the values, becomes different. So basically what we can say is that x is a tag for this 5. Like 5 can be called by x. So x is a tag for that 5. Like tag is something which we can call an object for. Like you go to a shopping complex, you see a jeans there, and you get a tag on a jeans that this jeans is this particular brand or this particular number, this particular model. So the tag basically defines a jeans. So similarly, this 5 is being defined by this x, and what does this x represent? This is a variable because this is containing the data. So another definition for this variable is that it is a tag for a data. Simple. This is a tag. So using that tag, you can just call that variable, you can just access that variable, you can just access that data. Fine. So summing up, this is a container, this is a container, this is called a variable because it contains data. So actually in a container, just see in real life, in a container you can just like put different kinds of objects. The object could be liquid, could be a solid, the container could be empty, which represents some gas in it. Different objects exist. Similarly, in computers, you can place different kinds of data in this container or in the variable, like different types of data that could be put into the container. Simple. Now in computer language, or let's say in normal language life, what types of data can you see? You can see a number, you can see alphabet, English alphabet, Hindi alphabet, something like that. You can say complete word, like alphabet represent to a single character and the word represent to the combination of all the characters. You can see something like decimal and lots of more. Okay, so on the same basis, like this is a data container, that means this is a variable. We can put different kinds of data into it. So actually it is important to define what kind of data we are going to put into the container, what kind of data we are going to put into the container. So the first type of data that we can put into a container is integer type. The keyword for this is int. You will not understand what does keyword mean, but you need to remember keyword for every type, at least for now. And in the end of this video, until the end of this video, you would be able to get how and where this keyword is being used and why is it important. Okay, so integer type. Integers, normally we know integers can be negative, 0, positive. They would be numbers, they will not be decimals anyway. So in normal life, in mathematics, integers can be from -infinity to infinity. Similar is for computers. Some exceptions are existing, I'll tell you one. Okay, so integers basically have two components. The first component being sign, the second component being value. Simple. Sign can be negative or positive. Like if there is no sign, we consider it to be positive. Simple. And it is a value. It has a value. The value is referred to as magnitude. So again, this integer type is being classified into further types depending upon these two properties. The first property is sign, the second property is value. On the basis of first property, sign, it is defined to be of two types. The first being signed and the other being unsigned. Like you try to understand what does signed mean. Signed means the integer will contain a sign. That means it could be negative, it could be positive. Obviously, if it is positive, you need not give a sign, but it is negative, you need to give a sign. So for unsigned, what does it mean? You need not, like, unsigned means it does not have a sign. And if any integer does not have a sign, what does it by default mean? It is just positive. So no need to put a sign, it would be just positive. So this is the first classification on the basis of sign. The second classification comes on the basis of value. See, in real life, integers can be from -infinity to infinity, but there exists a limitation for a computer. The memory of the computer is limited. It just cannot store a number that is tending to infinity or -infinity. So on the basis of it, we classify integers in a particular language. We classify integers in C++. We classify integers into particular types on the basis of their magnitude, so that the computer can efficiently manage its memory to store them. Okay, the first type is short. So what does short mean? Short is simply small integers, something between 1000, 2000, 3000, something like that. There is an exact number, but you need not remember that number. Just need to remember that short is used for smaller integers, something close to 5000. The next is long. Long is an integer that is quite long, something in millions, like 5 million, 6 million, 7 million, something like that. Long is an integer that is longest possible, that could be stored in a computer memory, like something to 8 digits or 9 digits, something like that. So there are specific numbers for all them, like there is a limit for all of them. I would attach the details in the description, you can check out there. You just need to go over it, you need not learn anything that is not of practical applications anyway. Okay, so two classifications that we made, the first one on the basis of sign and the second one on the basis of value. Like all these are keywords: short, long and long. Similarly, signed and unsigned. You need to remember all of them. We are going to use them and then you would understand how they're going to be used. Fine. The next type that we are going to enter into is decimal type. The keyword for it is, like, it has two keywords. We use them alternatively, float and double, and you'll get to know which one is being used when. Okay, same case for decimal exists. There are two cases on the basis of sign, on the basis of magnitude. The distinction exists in the fact that we do not classify decimals on the basis of sign, we just classify them on the basis of magnitude. What magnitude here means is that it just means number of places after a decimal, nothing more than that. This is what magnitude means in terms of decimal type. So three types: float, like quite smaller number of digits after decimal; double, larger number of digits after decimal; and then long double. Long double is something that has large number of digits after decimal. These are the examples. This could be one called float. This is a kind of double, and this is a long double, like lots and lots of digits after decimal, as you can see from here. Fine. Let's move on to the next data type. The next one is called character data type. The keyword is char, C-H-A-R. What is a character data type? It will contain only single character that is enclosed between a single quotes. Please remember, that is enclosed between a single quotes. If you try and enclose it between double quotes, you will make an error, you will make a mistake. That is completely different type. That needs a detailed discussion. That is a completely different data type. So try to remember, enclose only within single quotes, and then only it would be told as character. So the keyword I've already told you, this is char. This is what character data type means. The last one is the Boolean data type. So Boolean data type basically refers to one of the options, either yes or no. Simply, there are two options existing. The first option is yes, the another option is no. Like, I'll tell you some real life example. Someone asks you, have you had dinner? Okay, so the answer that you would give to him or her is that yes, I had dinner, or no, I didn't had. Simple. You are not going to tell that I had dinner, I had this, I had that, I had this dish, I had that dish. No way. You just need to answer in yes or no. This is what Boolean data type means. The keyword that is used is bool. So simply two cases exist, yes or no. In computer language, if a 0 is coming as a data, it will consider it as no. Quite simple. If 0 is coming as a data in integer form, it will consider it as no. So except 0 in integer form, like if there is a data that is not 0, except 0, any data that comes to the computer would be considered a yes, and know what? In computer, no corresponds to a 0 and yes corresponds to 1. Simple. Okay, this is what is written here. Yes means anything that is not 0, no means just 0. Let's take some examples. 1, 2, 3, 4, 5, something like that. 1 is not 0, so it corresponds to a yes, and it means in computer language 1. 2 is not 0, corresponds to yes, means 1. 3 is not 0, corresponds to yes, 1. 4 is not 0, corresponds to yes, 1. 5 is not 0, corresponds to yes, 1. 0 is 0, corresponds to no, that means 0. 1 is not 0, corresponds to yes, that means 1. ABC is not 0, corresponds to yes, that means 1. A is not 0, corresponds to yes, that means 1. Keep in mind, if you write something like this, this is 0 in inverted comma, this also corresponds to a yes, and thus corresponds to a 1. Only and only 0 in integer form corresponds to a no. That's it, nothing else. Fine. So moving on to the next data type. Next data type is string. String is the keyword that we use as string. String is nothing but combination of characters. Try and understand, string is nothing but combination of characters. Like you had characters A, B, C, D. I just combined them and I got a string A, B, C, D. Simple. Keep in mind, character that we studied earlier was something that was written in single inverted comma. String is something that is going to be written in double inverted comma. You need to remember this. Just changing the inverted commas from single to double or double to single changes the data type completely. Okay. So another example. So these are all the characters. I just combined all of them and I turned it into a string, and I used double quotes over it. Please remember. Okay. So we studied all the types of variables. We studied all the types of data that we are going to put into the variable. Fine. Now, the next topic that we are going to learn is declaration of variable. The next topic that we are going to learn is declaration of variable. So the basic syntax declaring the variable is, you give the data type, that means the keyword that I was talking about until now, the char, the int, the string, the bool, the float, the double, something like that, all of them, you need to use it properly according to your use case. Give the name of the data type, that means the keyword, give the space, and then give the variable name. So what does variable name actually mean? In simple mathematics, we had variables called x, y, z, a, b, c, something like that. Same will exist here. You just need to give a name of the variable so that in the next part of the program, you can access that particular data using that variable name. Like you need to remember that x, I've called this 5 as x, so that below in the program, if I want to use this 5, I will just call it by calling x. This is what variable name mean. Okay. So these are data types that we got to learn. Now we'll start declaring. We'll start with string. So simple syntax, just mention the keyword name, give a space, and write the variable name. Simple. So what does this do? This creates a data container that is called as x. The data container is called x, and it is going to contain some string. I don't know what string I'm going to store. I'll store it ahead. I'll not store it now. I'll tell you how to store data. This is just declaring variable. I'm just declaring a data container that is going to contain a string. I don't know what string is going to contain. That we'll study later on. Fine. For character, just write char, give a space, give a variable name. Same. Everything is same. Okay. For a bool, just give bool space z. Okay. So this creates a data container. So as you already knew, bool is just simple one thing, either 0 or 1. That means yes or no. You can give any data to z, but it will transform it into either 0 or 1. And we already learned how to transform any particular data into a 0 or a 1. That means into a boolean. So basically this data container is going to include only 0 or 1. That means 0 means yes and 0 means no, and 1 means yes. That's it. Okay. The next data type is float, like decimal. For decimal we had 3 types. Like first was float, so like after decimal smaller number of digits, double after decimal decent number of digits, and long double after decimal larger number of digits. So just mention the keyword float, double, long double, mention their variable names, and similar data containers are created with that particular name. Okay. So what is the use case of these 3 different types for decimal? Like if you get a decimal that is having large number of digits after decimal, just use this long double. It will handle all your data. It will not let it overflow. Like like the memory is limited, it will assign a memory so that it can store your long form of data, like larger form of data. Okay. Similarly, if you find your data to be of mediocre type, like mediocre length, just use double. And if you find that your decimal data is going to be smaller, like after decimal lesser number of digits are going to exist, just use float. Simple. Okay. I'll tell you, these are the most used, the float and the double. Long double is used very exceptionally when larger and larger number of digits are after the decimal. Basically we are going to use only these 2 types most of the times. This is going to be used in very exceptional cases, but you need to remember this. For basic use, for general use, you need to use only these 2. This will handle all your data. Fine. The last data type, the integer. For integer we had like int, we had this long, we have this long. Another one that we had is short. So int is the normal one, normal data. Long int, some larger integers. Long int, some further larger integers. Short int, like shorter integers. These are simply the variable names. similar algorithms, the data container is being created with this particular name, and that is going to contain integer, some shorter integers, some longer integers, something like that. Okay, so another classification that we had for integers is signed or unsigned. Like, you need not, if the integer is signed, it would be considered by default. You need not mention this. Like, if the integer is signed, it is by default. That means need not mention that. Simple. Don't need to mention that. No need to mention that if the integer is signed. If the integer is going to be unsigned, you need to mention, like in the declaration. How will you incorporate it? Simple. I'll write unsigned space int space and then the variable. Similarly, unsigned space long space int space b, unsigned space long space int space. Another thing that I would tell you is that int, long and long are three different kinds of data. So you can just for clarification, you can just remove those ints. It will still work. If you put that int, it will still work, but for this sake of convenience, you will write int a, long b, long c, and short, and for the short also we'll remove this int, short d, something like that. So four different kinds of data types under integers, and this unsigned is used like a contemporary part. Simply, if the integer is unsigned, we'll just use it, and if the integer is signed, it is by default. You need not use it. Even if you write signed int a, it is valid because the keyword is obviously existing, but be logical. No need to use this because by default the integer is signed. If you want to make it unsigned, like if you want the integer only to be positive, you just need to mention, like computer will get to know the integer that I am going to store is only going to be positive. It is not going to be negative. That's it. Okay. So next concept is for integer data type. So we knew that computer memory is limited. So let's suppose signed integer, obviously it would be negative, it would be positive. Let's suppose a computer memory that can contain integer from -10 to 10. That means simply it has 21 blocks. That means from -10 to 10 and including 0, it has 21 memory blocks in which it can store. Simple. So now let's decide that I'm not going to store negative integers, I'm just going to store positive integers. Now try to look here. The maximum magnitude that I could store is 10 if I take both signed and unsigned, like both negative and positive. Simple. Now let's just decide I want to store only unsigned integers. Like I have surety that in the program, in the data that I'm going to give, no negative integers are going to exist, only positive integers are going to exist. Since we have 21 blocks, the positive integers that we could store is 0 to 21. The observation that you need to make is the magnitude, the maximum magnitude increases. So this is an observation that you need to make. Let's suppose you have a large integer to store. Simply, you have large integer to store. Now if you try to use this signed integer data type, simple, signed integer, like you have this large integer and you know that it is not going to be negative, it is only going to be positive. Like sales for a company, it is going to be positive in crores, millions, billions, trillions, something like that, but it is never going to be negative. Simple. You know that the integer is going to be unsigned, but let's suppose you start using signed integers. Signed integers, you know the magnitude, the maximum magnitude that you get is lesser. So like you need to store this number. To store this number, the memory that you need to have is for that signed integer from something like that to something like that. Now point of observation is that the memory blocks in which these negative integers are going to be stored are being wasted. are being wasted, simply wasted, because we know that the integer that I'm going to store is going only to be positive. Simple. The negative space is being wasted. So what I did is that I just used this keyword unsigned in the variable declaration. So what it does is that the memory that was being wasted in this negative part just transferred into this positive part. So what now this becomes 0 to something like that. Okay, so the magnitude value that you could store is increases. So according to our task, we just modified the data type so that we could store even larger value. So what I would do is that instead of using only long int a, I would just write, like, if you use only long int a, it would mean signed integer. Signed integer would have lesser magnitude. So what I did is that I just used it as a whole, unsigned long int a. I would just remove this int for clarity. Unsigned long int a, like unsigned long a. So what does this do is that this just increases the maximum magnitude that I can store into the system, that I can store into the memory. So this is what signed and unsigned do to integer type. This is why they are important to manage memory. Okay, the next thing, the last thing that we're gonna do is that, like, we knew how to declare a variable, we just knew that. So like there is something called initialization of variable. Initialization of variable means, like, I'll tell you by example. I was just declaring this string x. Like, what does that mean? What does this mean? Actually, I am declaring a container that is being named x, and I am telling the computer that this is going to contain a string. I'm not telling the computer what string it is going to contain. What string is it going to contain? So the process in which I tell the computer that the container is going to contain the string, and I also tell the computer that what that string is going to be, what that data is going to be, is called initialization of variable. Like, we are going to give a value to this variable x. This is what we call initialization of variable. This is what we called initialization of variable. Like string x, this is what we did until now. What I'll do is that string x equal to ABC123 within double inverted commas to ensure that this is a string. We just put double inverted commas and we put it in front of it so that the computer now knows that the data container is going to be named x. It is going to contain a string, and the string that it is going to contain is ABC123. This is what initialization of variable means. So any variable can be initialized by just putting a as a, like, variable, like declaring a variable normally and putting a equal to and writing the value of variable. That's it. You need to write the proper variable here. Like if I try and write int a is equal to 5.1, this is going to give me an error. You simply know why. The variable type, the data type that I am declaring here is integer. The data that I am giving here is float, like decimal type. So the computer gets a contradiction. Like here you are telling that the data container is going to be of type int, and you are trying to store a float into it. This is where problem arises. So be careful. Store only that data which is of the particular data type that you are going to store in the variable. Simple. Another method to initialize the variable is that you just use this normal declaration of variable string x, and in the next line you can just declare this variable x is equal to ABC1. Similarly, I would just tell you for integers as well. How would it work? I would write int a, normal declaration of variable, and in the next line I would write a is equal to 10. These two lines will ensure that a data container is being created which is being named a, and the computer knows that the data container is going to contain data of type integer, and the data that it is holding currently is 10. So this is what you needed to learn as a basic in C++. Some more basic things are required that would be covered in next videos, but we would be starting some practical applications from the next videos as well after studying some more theoretical things. Fine. Until then, this was the content for today's video. So if you like the content, please do consider liking the video, subscribing the channel, sharing it with your friends. So until then, have a good day. Bye bye.